All right, so I'd like to look with you a bit at some of the things that we can see with our atoms and see how they're arranged, what they're made up of. So we mentioned last time that they're made of protons, neutrons, and electrons. So I'm going to ask you to look at a figure like this here, and we're going to see if you can guess what atom is what. What element is each one of these atoms? So if you take a look at sample A, you'll see there, according to the key, it's got one proton and one electron. So what would you suppose? What element is that supposed to represent? Okay, so you can refer to your periodic table. All right, now if you look there, we see one proton, one electron. If you said hydrogen, that is a good guess. That is what it is, hydrogen. So hydrogen, if you look at the periodic table, you'll find hydrogen up here in the top left corner. So hydrogen has a little number 1 up there in that black box. If you're looking at the ICS periodic table of the elements, has number 1 up there. Inside that black box, that is telling us the atomic number. Okay, so we'll see more of that. Take a look at the next one. Letter B. So what would that one be? There's a few good answers that you might guess there. For this one, you might see that this is helium. So why helium? You might have said beryllium, because beryllium has the number 4. I see 4 particles in the nucleus. But for the atomic number, we are only interested in the protons. So that black box shows us how many protons are in our atom. So on to letter C. Okay, you see that one there? And you say it is lithium, right? Lithium, 3 protons, and lithium is number 3. Okay, so now let's do letter D. Letter D has quite a few more protons, neutrons, and electrons. As you look at letter D, what is that? Well, I look and see that if I count those all up, it looks like it has 11 protons in it. So I would say that's sodium. Good. So there we are. So hydrogen, helium, lithium, and sodium are those 4 examples. Can I ask another question here? As you looked at the protons, what do you notice? Do you notice any patterns between electrons and protons and neutrons? You may note that the number of electrons is always equal to the number of protons when we have a regular atom. So if you know the atomic number tells us how many protons an atom has, it also tells us how many electrons it has. How about the neutrons? Well, you might look at the first couple of examples and say, well, the number of protons and neutrons are equal. Except, what about letter A? You might note letter A, usually hydrogen has no neutrons. It is just a proton with just 1 electron going around it. Can it have a neutron as well? Sure it can. If there is a neutron in there as well, then we'll have an isotope. We call an isotope of hydrogen. It still has the same atomic number, but it has more neutrons or less neutrons than the normal atom. All right, so then I'd like to look at one other thing on our periodic table. Here's that number 1. What about this other number there? For hydrogen, it's 1, or almost 1. 1.008. So what's that mean? Well, that will be what we call the atomic mass. The atomic mass tells us how many protons plus neutrons an atom has. So what's that mean for hydrogen? Does that mean it has 1 proton and 0.008 neutrons in it? Can it have part of a neutron and not a whole neutron? No. It has whole neutrons in it. What does it mean, though? It means only very seldom will you find a neutron in hydrogen. In fact, only 8 out of every 1,000, okay, it's not even quite that simple, but about 8 out of every 1,000 hydrogens would have a neutron and a proton in the nucleus. Okay? If you look at helium, helium has an atomic number of 2, and it has an atomic mass of 4. So what does that mean? Well, that means usually helium's going to have 2 protons and 2 neutrons. If you want to know how many neutrons an atom has, you take the mass number, which is protons plus neutrons, and then you subtract the number of protons, or the atomic number. And then whatever's left must be the number of neutrons. All right. So what about electrons? Why aren't we counting the electrons? Well, these electrons are very, very small. They do not have much mass at all. So adding extra electrons or taking away electrons does not significantly change the mass of that atom. So that tells us a little bit about what these look like. Again, is this really what our atoms look like? No. This is a model. So in this case, we're looking at the Bohr model, if you remember that. And we're looking at it because it can show us what energy level the different electrons are in. And that can be very important for us when we're looking at chemistry. Okay? So we'll get back to our atoms here in just a moment, but I'd like to take a moment to look at the periodic table and just see some of the things that it tells us. So there was a scientist named Mendeleev who looked at different elements, and he found that there were things that were consistent between different types of elements. So when he put them in order, he put them in order from in increasing atomic mass. And he found that there were patterns that kept repeating. It says, oh, this element acts like this one. And then the element next to that one acts like the element next to that one. And he found these repeating patterns. And so he started to put them together into a table like this. There were some things that didn't fit. Some elements looked like they were swapped. They weren't in the right spot. And people wondered, why is that? Why is it like that? As scientists learned more, years went by, we found that actually if we put them in order of their atomic number, that those inconsistencies work themselves out. So we say, oh, okay, well, now let's put it in order of atomic number. And so when you look at this periodic table that we use today, that's what we see. Atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, on down we go until we get down to hundreds. On ours, we have up to 109 listed, but there are more than that. Okay. So why is it shaped like this? Again, we look at those repeating patterns that we see. One thing that might look unusual about this is, if you look, there's 2 rows down here at the bottom that aren't connected to anything else. If you look at those, look carefully at those, can you see anything, any patterns, why they might be there? Or do they belong somewhere else? Can you find a place where it looks like they should be? Okay, take a look there. So I'm going to do a little modification of my periodic table. All right. So when I look at my periodic table, I see that there are some things next to each other that don't look like they fit next to each other. Okay. I've got cesium, barium, and then we have a gap. Okay. So it goes from number 56 to number 71. Well, where are those missing parts? Here they are. They're the ones down at the bottom. So if I wanted to fix my periodic table, bing, I'm going to tape it together. There we are. Now I have a real periodic table with everything in the right places. So why don't we see it like this in our books? This is how it makes sense. This is how it fits. Why do they give us this alternate version? Well, you might notice that it's kind of hard to fit it all on the screen here. So to fit it in books, we say, let's cut this long part out here and stick it down here at the bottom. Okay, so that is why the periodic table is like it is. Okay, so again, back over here, we have hydrogen and helium. Then we go down to another row. Why did we go down to another row when we got to lithium? Well, we have hydrogen, helium. Both of those have electrons just in the first energy level. If I look on here I've got lithium. Now, the first energy level can only hold 2 valence electrons, 2 electrons total. So once it has 2, it's all the way full. If I have 3, that third one won't fit. So that third one is bumped up into a high energy level. So that electron is going to have a whole lot more energy than the first 2 do. Then it's going to be a lot less stable than those first 2 are. So here we are with 2 in that first layer, and now we've got 1 in the second energy level. In this case, we have 1 valence electron because it is the highest energy level now. So that's lithium. If I look down here at my sodium, sodium has 2 in the first energy level. How many electrons are in the second energy level? If you count them up, 1, 2, 3, 4, 5, 6, 7, 8. 8 in the second. So the other energy levels will be able to hold 8 valence electrons. Once it's got 2 in the first level, 8 in the second level, they're full. They can't hold any more. So we have to bump up, and the next one goes in the third energy level. Again, this one is going in the high energy level. That electron is not very stable there. And so if it can, it wants to leave. It wants to go somewhere else where it can be in a lower energy state. We'll be getting to that as we learn more about this. Good. So we found lithium and sodium that had 1 valence electron. Can you make a guess? What do you think? What's something else that would have 1 valence electron? Another element? Good. If you said potassium or rubidium or cesium or francium, you might note, okay, here, all of these will end up with 1 valence electrons in this first row. So that is important because elements that have 1 valence electron tend to react in similar ways to other elements that have 1 valence electron. Okay? Good. So now we're going to take a look at how we might make our electron dot diagrams, or Lewis diagrams, we said. We took a quick look at this when we were together. Let's see if we can get this. So when we are doing those Lewis diagrams, which electrons are we going to put dots for? So we'll put the chemical symbol HLI, Na. We'll put that in the middle. And then for these, what electrons do we care about to put dots around? So if we have hydrogen, we've got 1 electron, we put 1 dot. Okay? If we have lithium, we are only concerned with the valence electrons. So we'll put Li, and then we put 1 dot next to Li. Do we care if that 1 dot is on the right or on the left or on the top or on the bottom? No. It can be put anywhere. And later on, when we start using these to find out how different elements combine together, it will become obvious where we should put those. But for right now, just know that you can put it on any side you want. Again, if we go down here to sodium, sodium has lots of electrons. How many of them are valence electrons? Only 1, right? So we don't count the ones in the middle here, just the one on the outside. The ones in the highest energy level, these valence electrons, those are the ones that are going to allow this atom to react with other atoms. Okay, so that's what we have. One more rule for making electron dot diagrams is that you put 1 dot on any side you want to start off, and then you put another dot if there's 2 valence electrons, but you don't put those 2 dots on the same side. You have to put 1 on one side, 1 on another. And then if you have 3 or 4, make sure there's only 1 on each side. So if you have 4 valence electrons, like carbon, say 1 on top, 1 on bottom, 1 on the left, 1 on the right. Okay? If you get more than 4 valence electrons, 5, 6, 7, 8, then you start doubling them up. And then in the end, if you have 8 valence electrons, you are full. You can't put any more than 8 valence electrons on these. Okay, so to start off, we'll just be looking at a few of these groups of elements, and we'll skip a section in the middle, and I'm going to ask you to try to start getting familiar with the periodic table. So I'm going to ask you to look at the periodic table and to find some things about it. So I want you to find the symbol SiNaHO. I'll ask you to find the atomic number, and I'll also ask you to find the atomic mass. And right now, I'm just wanting you to get familiar, to look around, and as you go through these, you'll become more and more familiar, and it will take you less and less time to find the elements in the periodic table. Okay, so later on we'll have an activity where you can look around and find things in the periodic table. All right, so I hope that's helpful. If you have questions about this, you can always ask me. You can go into Google Classroom or send me an email and try out this assignment, see if you can figure out the things that you need to know, and then we'll try to make sure you're in good shape. After this, we'll be looking at the different groups that we can see in the periodic table. Very well, I wish you the best this week, and we'll see you later.